Welcome to today's presentation. In today's presentation, I'm going to look at exterior angles of a regular polygon. So in this video, I'm going to share with you the property you can use to find the exterior angle of any given regular polygon. And later on, we're going to conclude coming up with a sum of exterior angles, of any given polygon. So with that being said, I encourage you to subscribe to our YouTube channel. Also invite your friends to subscribe to our YouTube channel, and remember to share this video if you find it helpful. Now let's get into finding the exterior angle of a regular polygon. Okay, before I go into finding the exterior angle of a regular polygon, I want to look up on the interior angle of a regular polygon. Now I'm going to use the triangle, which is called equilateral triangle, to look up on what we said. Okay, when we looked at interior angle of a regular polygon, we said every angle in a regular polygon is equal to other angle. Okay, so we are saying all angles in a regular polygon are equal. So like you can see here, we have got a regular polygon which is a triangle, which is called equilateral triangle. And you can see that all the interior angles of this regular polygon is 60 degrees. Okay, now let's imagine that the lines that are forming this triangle are extended. If we can extend this line like this, okay, if all the lines are extended like this one, where we have got angle A, angle B, and angle C. Okay, what is the value of angle A? What is the value of angle B, and what is the value of angle C? Okay, so to find the value of angle A and to find the value of exterior angles, because angle A, angle B, and angle C are exterior angles. Okay, they are exterior angles of each respective angle. Even if the angle they are the same, you can see that where there is angle A, there is in an interior angle of 60 degrees. Okay, A is an exterior angle, but 60 degrees inside the triangle is the interior angle of a triangle. Okay, I should also remind you viewers that this triangle is not drawn to measurement, so you can see other sides are longer than the others, so it's not drawn to the measurement, but you can see those lines that are cutting across the lines. We have got one line in each line. That means they are saying these lines are equal. Okay, so when we look at A, it's an exterior angle of 60 degrees, and B is an exterior angle of that interior angle 60 degrees, and C. So these three ABC angles are exterior angles of this triangle. So how do we find the value of A, B, and C? To find the value of A, B, and C, we are going to use a property of angles on a straight line add up to 180. That's a property we are going to use, which is angles on a straight line add up to 180. Okay, so when we use that property, we are able to find the value of A, B, and C. Okay, as you can see, when we look at the angle A, when you look at that, you may see that 60 degrees and angle A are adjacent angles on a straight line. Okay, on a straight line. So they are made by the same vertex as well as the same arm, so they are adjacent to each other. Then that means they add up. They are only one straight line. That means they can add up to 180. So to find the value of A, we are going to use the property which is angles on a straight line add up to 180. So that means when we add the 60 degrees to A, it should give us 180. When we add 60 degrees to A, it should give us 180, which we can write as 60 plus A is equal to 180. Now there, I'm sure if you have been following us, that is now simple for you to find the value of A. So what we're going to do is we're going to make A subject of the formula, which is going to be minus A is equal to 180 degrees minus 60 degrees, which should give us A is equal to 120 degrees. Okay, so the value of angle A is 120 degrees. Now that is the value of angle A. Okay, 120 degrees. Okay, then let's find the value of B. If we are to find the value of B, we are going to carry out the same steps. If you are not sure on how to find a unknown angle by using the property of angles on a straight line, you can watch our previous video where we demonstrated on how to find the unknown angle using the property of angles on a straight line. We did that extensively, so you can check on our video. I'll also put the link in the description box. Okay, so once you have found for A, you can go ahead and find for B. So we're going to carry out the same steps. So where there is A, we're just going to put B, and if you go through that, you're going to find that when you write 60 degrees plus B is equal to 180 degrees, you are going to put the like terms together, which is going to give you B is equal to 180 degrees minus 60 degrees, which should also give you 120 degrees. So the value of B is 120 degrees. This is the same with the C. When you put C, you're going to get the final answer, which is 120 degrees. Now, when you look at the answers, the values of these letters were found. We have found that the value of C to A is just the same. Okay, the value of A is 120 degrees, the value of B is 120 degrees, the value of C is 120 degrees. This fulfills the characteristics of a polygon, a regular polygon. If you remember, in our previous video, we said the regular polygon has got equal sides, equal interior angles, and equal exterior angles. So as you can see, this is a regular polygon, and it has got equal exterior angles and equal interior angles. Okay, so now what I want us to do is on the right side, on the top right side of the screen, we'll be writing the sum of exterior angles. Okay, so I'll be writing the sum of exterior angles on the right corner there. So I'm going to write 120 degrees times 3. So as you can see, there are 3 exterior angles of the regular polygon, which is a equilateral triangle. There are 3 sides of, there are 3 exterior angles of a equilateral triangle. So I'm going to multiply them by 3. Since there are 3, that means I'm going to multiply 120 by 3, or I'm going to add them. 120 degrees plus 120 degrees plus 120 degrees, which will give me 360 degrees. Now 360 degrees is the sum of the exterior angles of an equilateral triangle. Then I'm going to reduce this. Okay, then I'm going to look at another regular polygon. I'm going to use this one, which is the Pentagon. Now that is a pentagon drawn. Now when you look at this pentagon shape, you'll see that there is X there, which is indicated by a lady X there, and then there is also 180 degrees. So that is what I'm going to focus on, the X there and 180 degrees there. Okay, that's what I'm going to focus on. I'm going to focus on those two details that are given. Now as you can see, that is that is 180 degrees is the interior angle of the regular pentagon. It's the interior angle of a regular pentagon. That means every angle in the pentagon is 108 degrees. Okay, as usual, this pentagon is not drawn to the measurements. If you see any different angle, please presume that it's a regular polygon. Even if it can give you 90 degrees, presume that it's 180 degrees, because every angle there, the interior angle is equal. So now that means even the interior angle of the point where X is 180 degrees. So every angle is 180 degrees. Okay, now once we have identified the interior angle of a point where X is, then we can say that angle X and angle 180, they are on a straight line. Okay, they are on a straight line. So that means the straight line that is going upwards, not this one which is lying horizontally, the one that's going upwards. So we're saying X and 108 there, adjacent angles which are made on a straight line. And remember, we're going to use the same property, which is angles on a straight line add up to 180. So to do that, that means we are going to add x to 180 degrees. So it's going to be like this, x plus 180 degrees. Now lines on the angles on a straight line add up to 180, so which is going to be equal to 180 degrees. Okay, so we're going to put like terms together as usual. So we're going to have x is equal to 180 degrees minus 180 degrees, okay, which is going to give us x is equal to 72 degrees. So the value of x is 72 degrees. Okay, now as you can see that the the regular polygon given is a pentagon, and we know that pentagon have got 5 exterior angles. That means we're going to multiply 72 by 5, which we are going to do again there on the top right of the screen, which is going to be 72 multiplied by 5, which I'm sure is going to give us 360 degrees. Now, even if the pentagon has got a bigger number of angles, you can see that the answer it has given us is the same as the answer we got in the sum of the angles in the equilateral triangle and in the regular polygon is the same, 360 degrees, despite that the pentagon has got a bigger number of angles. Okay, once I've done that, now I'm going to reduce this. Okay, let me remove that. Okay, I'm going to reduce this and this. Okay, now once I've done that, then the next thing I'm going to do is I'm going to also bring out another example. Okay, let's look at this one. Okay, this is the example given. Now when you look at this regular polygon, when you count the sides, you find that this regular polygon has got 8 sides. It has 8 sides. So this is obviously an octagon. Okay, it's an octagon polygon. Okay, it has got 8 sides. So what we're going to do now, we're going to find the value of the inner triangle or interior triangle. So the interior triangle of a octagon is, now that is a regular octagon. The interior angle of a regular octagon is 335 degrees. The interior angle of the octagon, regular octagon, is 135 degrees. You see, 135 degrees. Now when you look at that angle, you can see that there is also an exterior angle of y. Okay, they are all lying on a straight line. Now when you look at that line that is going upwards, you see that that's the arm of 135 degrees and y. Okay, so you can see that 135 degrees is an adjacent angle to y degree. Okay, so they are lying on the same straight line and sharing the same arm and the vertex, so they are adjacent angles there. Okay, even here you're going to use the property of angles on a straight line add up to 180 degrees. Okay, so what we're going to do now, we are going to use the same expression where we add y to 135 degrees to give us 180 degrees. Now remember, in this question, the examiners or whoever is asking you the question is relying on the fact that in your height, you know the name of the angle, the shape, the polygon given, which is octagon, and you also knows that this number of sides this polygon has, as well as the angles it has. Then you also know the sum of this of the interior angles of this polygon, as well as the value of one angle of this regular polygon. Okay, that is this question is coming with that they believe that you know all that. Okay, so now since we know the angle, the interior angle, the value of one interior angle of this polygon, then we can find the exterior angle. Okay, like I said, yeah, it said earlier on, these two angles, 135 degrees and y, they are lying on the same straight line. That means now we can now write y plus 135 degrees is equal to 180 degrees. Y plus 135 degrees is equal to 180 degrees. Then we are going to put like terms together as usual. So we're going to have y is equal to 180 degrees minus 135 degrees. Okay. Then when we calculate that, it's going to give us y is equal to 45 degrees. Now, that is the value of the exterior angle of this polygon. Now, this means that every exterior angle of this polygon is equal to 45 degrees. So now, we are going to go on the right, on the top right of the top right corner of this screen, where we're going to continue writing. Now, we found that a polygon with the 8 sides has got exterior angle of 45 degrees. So a regular polygon of 8 sides has got the exterior angle of 45 degrees, which is going to be 45 degrees multiplied by 8. So 45 degrees multiplied by 8 will give us 360 degrees. Okay, so that is, now I can also reduce that. Okay, now when you look at this, even if the polygon, a regular polygon, has got different number of sides and angles, the answer we are getting, the sum of angles is 360 degrees. So this is the fact. When you try any number of sides a polygon may have, or any number of exterior angles any polygon, a regular polygon can have, or polygon can have, it will give you a sum of 360 degrees. Okay, so therefore we can say all exterior angles of a polygon add up to 360 degrees. This is the other property you should also know. So if you have found the exterior angle of a certain polygon, to confirm whether your answer is correct, before you even make the submissions, you may try to add all the angles, whether it's regular or irregular. You try to add all the exterior angles. If you find that the sum is 360 degrees, that means the answer you got is correct. If it is in our case, you just multiply the angles, the value of that angle, by the number of angles. Then if you find that the answer is 360 degrees, that means the answer is correct. So basically, this is how you can find the exterior angle of a given regular polygon. If you have got questions, you can ask in the comment section. Otherwise, thank you so much for watching. It has been Easy Learning Z Mathematics. The future is bright. See you in the next video, and God bless you.